Hey there. So, in this lesson, we'll be talking about area. So, what is area? It's essentially the total space taken up by a flat 2D surface, shape, or object. So is the surface area, in a sense. And if you don't already know, the surface area will always be, the units for the surface area will always be squared, whether it's centimeters squared, or meters squared, or feet squared. It will always be squared, whereas volume is cubed. And that's something you should already know, but if you don't, there we go. Okay, so I have a couple of shapes and a couple of formulas here. Let me just get my comment tool here. Hmm, Oh, it's blue. That's okay. So, so for a rectangle, the formula is length times width for a rectangle. However, for a square, it's the same formula, but if you think about it, the length and the width are equal to each other. So in short, you can say length squared or width squared, either or. So that's for that formula. But you also know you have to know the area of a circle. Um, and I think these are just the basic shapes that you need to know. There are other shapes, but these are the basic ones that I believe that you will come across. So it's pi times r squared. And you should already know that pi will always equal 3.14. So, and also, you should also know the diameter. If there's a question that says diameter, basically the radius is half the diameter. So if the diameter from here to here, if it's 4, if it's 4, then the radius, let's say it says 4 centimeters. Therefore, the radius, which is from here to here, will be only be 2 centimeters. Again, the radius is always half of the diameter. That's just in case you come across a problem like that. Now the area for a triangle. It is the base times height. And the height, in this case, is from, and it's parallel down from here to here. So that's the height. Or maybe I should undo that. Here. From there all the way down to there, the height. And the base is from there to there. And this applies to any triangle, all triangles. So it's the base times height divided by 2. This here is just another way of expressing divided by 2. I put it over here so it's a little bit easier, guys, to understand. And the best way to do these problems, well, let's talk about a composite figure. So you're not going to get simple shapes. You're gonna have a bunch of shapes put together. And in reality, most shapes that we see are put together. So that's what a composite figure is. And the best way to completely to understand area is to do problems. So let's do the first problem. The area of a composite figure. So a fire marshal needs to know the area of a club of the club's dance floor. The illustration is here. We have the mosh pit, and we have two shapes here we can see. Now, to solve these problems, sometimes you have to be a little bit what's the word? You gotta be a little bit um creative, because essentially I know this is a circle. Like this is so I know it's a half a circle. So I'm assuming this is gonna be half a circle. And you're gonna have to know what the radius is from here down to here. However, I do know that the whole thing from here to here is 13, and from here to here is 8 meters. So I can say from here to here, remember the whole thing is 13, right? The whole thing is 13 meters. So 13 minus 8, let's pop that in a calculator. 13 minus 8, that will give us 5. So let me just double check that. 13 minus 8, so that's 5. So this here is actually 5 meters. So we just did that. We did a quick calculation for that, but I'll do more of it here. Let me just write down meters here. Or meters, yeah, just meters. Okay, so again, there's two shapes, so we might as well find the area of both shapes. And what I like to do, like use A for area, that we always do, and then in subscript, we write the description of the area. So I'm just gonna say main, and that's small, main. So the area of the main, and it's basically length times width in short, which is, well, the length, well, you can take either or, length or width, doesn't matter which one. So we're just looking at this area here. This is the area of the main, and this will be area of the circle, or half the circle in this case, circle. Yeah, so it's basically half the circle. Yeah, so there you go. Area of the main. So length times width. I am going to put right over here 8 times 10. And I know that's going to equal 80. That'll be, again, area is always expressed as meters squared. I believe it's in meters. So let me just erase that and put meters squared. So that's that part there. And then let's figure out the area of the circle. Well, it's half a circle to be in reality. So you figure out the area of the circle, then you just divide it by 2. So our formula for the circle is pi r squared, right? And again, because this is half a circle, maybe we should put, well, half a circle, we're just going to divide it by 2. There we go. Let's drop in our numbers. Again, pi, you should already know. It's a very famous number, so something you should already know. It's always going to be 3.14 if you don't already know it. So pi will always equal, like, that's just a constant number that you'll always come across. And so just like in most problems, they don't mention what the value of pi is, but it's something you should remember. Always remember that pi is always 3.14. And on a test, I'll probably give it on the test or quiz, but so this is something you should know. So r, see in this case here, r is our radius. We're looking at the circle. We know that, oh, we actually know, you can tell right here the diameter. So you can, I figured it out this way, but you can also figure it out this way because you know the diameter itself is 10 meters. We can see down over here, 10 meters. So this is 10 meters, right? So half of that with 5 meters, which is this one. They're exactly the same. So we have 5 meters, and you know it's squared, and I'm just going to divide it by 2. Let's drop that into the calculator and see what we get. 3.14 times uh, 5 squared, and then divide by 2. And we get a number of 39.25. 39.25 meters squared. So for the total area, I'm going to write down area here, and then I'm going to say total. That's going to be, let me just get a little bit, we have some room. That's going to be 80, which is that number here, that 80 meters squared, plus 39.25 meters squared, and that will be a total of 119.3, and the units will be meters squared. So there we go. That's that problem. That's done. So again, I know this is a circle, but it's really half a circle. So I'm just gonna say, I'm gonna say half. That's where that 2 comes from. So this is half. That's where this half part comes on. That's half a circle. Okie dokie. So next problem. Well, the net. We'll talk about net area. Net area is basically the remain. It means remaining area. So the area found by subtracting one or more areas from the total. So sometimes, or not sometimes, but a lot of times, you're going to have to find the net area. So you find the bigger area and you subtract it by the smaller area. And that's typically how I sort of rationalize it. So, example 2. Nazar installs interlocking bricks between two triangle gardens in his backyard as shown. Determine the area to be covered with interlocking bricks. Okay, so basically you want to find all this area right here, the brick area. And what it really means is, like, if you have a backyard in your house, and sometimes I don't like the grass, so I want to brick up the grass, get rid of all my grass and put bricks in it. This is exactly what's happening here, except he wants to brick up this specific shape in his backyard. Okay, so the first step we do in most of these net area problems, again, you have to be sort of creative to like understand and solve these problems. So I can tell right away that I want to find the whole area of the backyard. So let's do that. And this is the whole thing, the whole the whole area of the backyard. So we're gonna do the area, and I'm gonna say maybe backyard, or just call area back. And that's gonna be again length times width, which is 15 multiplied by 24. And that will be about um, 360 meters squared. So that's for the whole backyard. Now let's find the area of the garden part, and we're gonna subtract. The reason we want to find it is because we're gonna subtract it by the whole backyard. But first, let's find the area of the two garden parts. So these two parts right here, and they're the exact same parts. So we just have to find one, and just multiply it by two. So I'm gonna say the area of, let's say, the what I call it, garden. There we go, subscript garden, and that is going to equal a triangle, and then we can multiply by 2. So two triangles, 2 times, and then the formula for the triangle is base times height divided by 2. You can put these in brackets if you want, but you don't have to. Like, you can say like that if you want, if it's easier for you to understand. So let's drop our numbers in. And let's see, base. What's our base? Well, you see these ticks here? This ticks means it's the exact same length. So if this is 11, then this is 11 here. And this is 11. And then this is 11. A single tick. If it's so that's what they mean. That's what they're trying to indicate, because it's these books, they often don't want to spend a lot of time repeating itself, so they use these ticks to say that's exactly the same. So in this case, the base will be 11 meters multiplied. I'm going to use a square bracket here. Multiplied by 11 meters, or I could have said 11 meters squared, either or, and divided by 2. Let's see what we get. I believe we should get 121 meters squared. There we go. And that's for the whole garden. So it's two of these triangles. Now, what we're going to do is we're going to subtract the area, the total area of the backyard minus this garden part. So I'm going to say area, and again, use the word A for area, and then in subscript, you write down the description. So this will be net. Like, use anything you want, but net is a very good description of what we're looking for. We're looking for the net area. So basically, the area of the backyard, I think I named it back, minus the area of the garden, which we know is 360 minus 121, and that's going to equal 239. 239 meters squared. There we go. Okay, so these problems are thus easy thus far, but you may come across, this is probably the most difficult problem you'll come across here, the cost to paint a wall, and also you probably need to do a conversion. Remember, when you're working these problems, you got to make sure you're working all in the same units. So here it's feet, 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 but over here it's meters. And later on, I will convert this into feet. But before we do that, let's find the area of the walls. And I see here from this shape, it's actually two shapes. There's a triangle part. This is the roof. I'm gonna say roof here. That's the roof. And this is just the wall part here. And to find the height, the height of this, because you know from here, like from here to here, like basically you want to find the height here, but you know from here to here, all the way across, you know that's gonna be 19, right? So 19 minus 12, define it. So it's 19 minus 12 gives us 7. So over here, it's about 7 feet. And they're there. Oops, let's leave that there. Good. And I don't know if you can see this, but the paint costs $50.20. So if you can't see, if it's a little bit small, it's per can. So $50.20, and that is per can. Okay, let's find the area of the wall. And this is including the windows. So we're just gonna find well, this area here, this part here of the wall. Well, not just the wall, the area of the wall, and then well, yeah. So we have to find the area of the wall and the area of the roof, or just the area of the wall together. So I'm gonna break this down into two problems, two shapes. I'm gonna say, actually, let me erase this. I don't want to get confused, you guys. I'm gonna say that this will be the area of the rectangle, and this will be the area of the triangle, area of the triangle. I'm just gonna use triangle there. So the area of the rectangle. Let's do that first. Rec. I'm just gonna say rect, and the area of the rectangle. That's length times width there, and that will be 25. I'm just gonna use the brackets there. Brackets are easier to see than these thing is with these multiplication signs. The x and the multiplication, they look very similar. That's why I don't like using that multiplication sign. I like to use the brackets instead because it's a lot cleaner to look at. Okay, 25 times 12, because this part here, that's 25 across, and up here is 12, and that is going to equal, I'm just gonna put over here, that is going to equal about 300 feet squared. Now let's find the area of the triangle. Oops. I'm going to say TRIG. Try. There. And again, that is base times height divided by 2. And the base here, from here to here, is going to be 25. The height we found earlier is 7. Or basically, it's basically 19 minus 12 will gives us 7. That's how we find this right here. And then I would say a lot of times you're going to have to do that. Like, you're going to give you the entire length, and then you're going to subtract some of the length to find this part. So you're going to see that a lot. So that's something worthwhile to remember. And we have here 18 feet. No, not 18. We have 87.5. 87.5 feet squared. And together, let me see if I have room down here. Oh, this, well, I guess you can say total. You can say A, the wall, or A, yeah, the A, it's called the wall, will be A, the rectangle, plus A, area, the triangle, and let's drop our numbers in, which is 300 plus 87.5, and that gives us, let's take a look here, that gives us 387, 300, oops, 387.5 feet squared. Oops, feet there. Feet squared. There we go. That's, so we found the area of the wall, and that's with the windows. With the windows. Now let's find the area of the windows. Now, I'm gonna say windows or windows. That's fine. Windows. Okay, so there's two windows, so we're gonna multiply it by two. But this here is a square, so I would say in each side this is 3 feet and up is 3 feet. So 3 feet by 3 feet, because this over here is also 3 feet. That's what these ticks mean. So you can say 3 feet times 3, and in this case that would equal 18 feet squared. Okay, then finally we are going to calculate the area without the windows. So that is what we're going to say, area net. Okay, description is net, and it's essentially the area of the wall, which is the total area, minus the area of the windows. I should put an S here for windows. And that will be 387.5 minus 18. And that should give me, let's put it over here. Let's erase that. Let's put it over there. And that should give me 369, 369.5, 69.5, and that is feet squared. So now we have the net, and here's a diagram that's showing what's happening. Now, again, here's the sort of a hard part, because if you want to find we got to find the paint units first, because, and we're going to convert from meters to feet, because up here, it says here every can of paint will cover 4.5 meters, right? So let's transform that into um, feet squared. So say the area of the paint. And I want to show you something. I want to show every conversion, or 90% of all conversions you'll ever see, is done the same way. So you write down the information you have, which is 45, and I believe it is meters squared. I believe, let's take a look up here. 45 meters squared. That's the paint. It says right on the can, on the paint here, like right over there. 45 meters squared. That's where it says it right there. So this is 45 meters squared. And every conversion is done the same way. So you do this, a multiplication sign here, and top and bottom. The top is what you want. The bottom is the conversion. So let's look up here. I wrote down the conversion over here. Here it is. 1 meter squared. 1 meter squared is equivalent to 10.7639 feet squared. So you have two numbers there, and here's two spaces. So this is 10.7639. This will go on top. 10 point, what was it, 3? Oops. 7639. And that is feet squared. And that will be over 1 meter squared. And the reason I have it arranged like this is because this here is on top. This meter is on top because underneath here is really a 1. And so it cancels out with that, and this cancels out here. And so essentially, you end up with 400 and 484.38 feet squared. So that's the every can of paint can cover this much area. Now, how many cans of paint do we need? Well, again, it's because it's 2 coats, we're gonna need twice as much. But how much is it just for 1 coat? So let's take a look. So basically, the number of cans, I'm gonna say number of cans that we need would be the total area of the net area. So area net. Actually, maybe let's go back because we know we need 2 cans, right? So I might as well start off with 2 times, and over here, the area of the net area of the wall. Is that right? Yeah, the net area of the wall divided by how much 1 can will cover, which is about, well, the area of the paint. Paint right there. There we go. Let's drop our numbers in. 2 times, and the net is 369.5 divided by 484.38, and that should equal 1.52 cans. 1.52 cans. So essentially, in short, about 2 cans. You need at least 2 cans because you can't buy half a can, right? So you need 2 cans. So you need 2 cans of paint. Now the cost of 2 cans, we know the cost of 1 can. So if you need 2 cans, like, well, let's take a look at the cost. So the cost, I'm gonna put a dollar sign right here, is essentially we need 2 cans, right? So 2 cans multiplied by the price. The price of 1 can says here it's $50.20 per can. So 2 cans times 50.20, and that will equal about 100. And let's put that in dollar signs. 100 and, well, it's $100. 140 cents. $100.40. And that's about it. There we go. So, that's how you solve this problem. This is as hard as you'll probably get. Um, and maybe these half circles might be a little bit tricky too here. Other than that, yeah, I hope you're following along, and good luck with the homework.